So Laura, how are we doing on participants? Are we there?
Yes.
We can start when you're ready.
All right. Welcome everyone to the Code Review Committee for the adoption of the 2025 Oregon Mechanical Specialty Code based on the current 2022 Mechanical Code with integration of the 2024 International Mechanical Code.
Mark, before you get
Yes.
busy, I need to do a comm check.
Yep, we can hear you
Copy.
good.
Thank you. Also, do we
Yes.
expect to go fully until 3:30?
I think this should go fairly quickly, hopefully, today.
Thank you.
All right. So this is to pick up on the review of the matrix and the open items today, including some that were tabled from last week that we're going to look at, as well as reviewing dwelling unit ventilation in R2, R3, and R4 occupancies, as well as a one open piece that was relative to refrigerant piping and shafts. And I believe there was also going to be a little, trying to find the matrix item. We're going to look at a little bit more detail, yes, potential on the intake and exhaust outlet location items. I think that's one of the Chapter 5 items we were going to look at. And then after we're done with that, look at all, just sort of one last chance to look at the sections and the matrix before forwarding to the any other discussion items before we forward this to the mechanical board for their review and approval. If we don't get through it today, which I'm hoping we do, I think it should be fairly quick. We can schedule another meeting. At this point, though, I'd like to turn it over to Pierre with the division to go through quickly as we sort of some of the background items that we have to do as we're walking through code items, especially with some of the noting whether something has a cost impact or not, sort of the statements as we go through and how we'll wrap this up today. So do you mind, Pierre?
Yeah, what did you want me to go through what we went through last time?
Yes, just for everyone to remind them once again as we start out on this.
Okay, so going through our matrix from last time, if you look at Chapter 5, 5016 common ducts, we had said at the last meeting that there will be a slight cost increase. And if you look at the matrix, the ICC explains that there's a potential code increase only where the cost of an additional roof, wall, or soffit penetration is more than the cost of larger common ducts. So that was one we flagged with a potential cost increase. Nothing else in Chapter 5. Chapter 6, we had no other fiscals that we had flagged. 7 and 8, nothing. Going down to 9, we had nothing. 10, nothing. 11, I know we are going to. Are we circling back on the discussion on 1101, Mark?
We will be circling back a little bit, but just to make sure that when we go through, just a reminder to everyone that when we look at a section and discuss it, that we just have to remember to say, yes, we feel that there is a cost impact or not.
Yes.
So when some things go forward, just a reminder for the general process today as we go through items. So with that, I would like to go to, and if we can, excuse me.
Sorry, Mark, I was going to flag I was going to mention one more thing.
Yes.
But sorry, my Citrix is deciding to absolutely poop out. Okay, here we go. Sorry. We did, there was a Chapter 4 decrease in Fiscal 2 for the minimum ventilation rates that I wanted to flag for everybody. We had mentioned the possible decrease.
Yeah.
So So I think that's everything covered, but if I miss one, let me know.
All right. So today, per the agenda, we're going to look at tabled items first. If we can bring up on the screen item or section 501.3.1. We were going to, and I believe, I'm trying to remember, someone was, one of the committee members was going to come back with a little extra discussion today on that section. So if we could bring on the screen section 501.3.1.
Yeah, Mark, and this is Tim here. I was the
Tim.
one that mentioned it. I have I think what's a kind of a small proposed edit here for consideration. I can either share my screen or tell you what it would be. It's a slight addition to number 3 under 501.3.1.
Yes,
I
go for it.
believe. Go ahead.
Cool. So this would be clarifying here for all environmental air exhausts, 3 feet from property lines, 3 feet from operable openings, 10 feet from mechanical air intakes, or as determined by the methodology described in ASHRAE 62.1 2022 normative appendix B, which is a calculation method to determine the separation distance required based on velocity. So that would apply only to environmental air. But I believe that's generally considered an acceptable alternative method, though it's not called out explicitly. Correct me if you know otherwise. And I can
It
share
is
that.
not called out explicitly, and I'll do a quick word search. So when there are items that are in section 4 specifically to 62.1, it's only mentioned really once. And so while it's still allowed under, when you get to some of the methodologies, it would be having this noted specifically in code would probably be a good, would show that it's a known accepted methodology, I guess. That would be, having it more specifically noted for this would probably assist. But leave that up to the
Mark, I guess I'd add I don't have strong feelings about it. And, this is my first code review committee, so I don't consider myself the authority on whether or not things should be called out explicitly, whether and where. But it's something that's come up for me in the past, so thought I'd mention it. But I have no strong feelings, so I'll leave it at that.
In the past, in some past editions for mechanical ventilation, we've had old code would sometimes say under the I-code methodology or the use of 62.1 was always allowed. Indirectly, it's always allowed, but this would be from our standpoint, would provide a little extra flexibility without having to go through an appeal process or additional items for, doing what is an accepted methodology and well-respected methodology for discharge of, yes, again, it's environmental air. This could be a, whether it's just from bathroom exhaust, general ventilation exhaust, residential range hoods, and a few other items are considered environmental air. So this wouldn't be any air that's, and this would allow it to be closer to a mechanical intake. And
especially applicable to multifamily, maybe in cases where you're not literally using the concentric intake and exhaust, but have some other solution. The concentric being the already allowed factory built intake exhaust combination termination fitting.
Any feedback from the committee?
Well, first of all, what's environmental air? All air is environmental.
By
Is there a definition of it?
yes, let's go back here to
Just as long as there's a definition of it, because
so environmental air is that conveyed to or from occupied areas through ducts that are not part of the heating or air conditioning system, such as ventilation for human usage, domestic range exhaust, bathroom exhaust, clothes dryer exhaust, and parking garage exhaust. So it's not any of the hazardous materials. It's basically general space air being
Okay.
exhausted
all right.
or used.
Mark, is it a decision we need to make now, or can it just, go down as a proposal and get decided another time?
It's up for discussion today. And let's see here. We can on input from committee members. Let's see here. Kevin? Or Kevin, you're on this, or I'm trying to remember all our committee.
Yeah, I'm not on the committee, but I'm on the board. But I just wanted to say, I think Tim's proposal is great. That's it.
So we have to be cognizant of time and so forth. But yes, I'm seeing one other comment, and we'll get this through. Then the remainder will need to be from the committee. Mike Moore.
Thanks, Mark. Yeah, just for information purposes, 62.2 is also being modified to reduce the separation distance, minimum separation distance required. So ASHRAE 62.2. So you guys might want to reference ASHRAE 62.2 2025 edition. There's an addendum that's almost published right now and for 62.2 2022 to be part of the 2025. And and that would give you more flexibility. You could just reference 62.2 2025 potentially. Again, it's not published, so that might limit your ability to do that.
Yeah, that does limit our ability, but knowing that that's out there is something that for now we can use what is published. So this would be the easiest thing for today. So any objections from the committee to putting in that recommendation to the main board? And then yes, in a future day, we can look back at the 62.2 portions and items for next code cycle or statewide interpretation or an alternate method at some point. So for multifamily, anything that would provide a little extra flexibility for them would be great. But this is a nice path for, let's say, a bathroom fan from a strip mall or something like that as well. So it's providing that flexibility in the commercial side, and then, but we'll also allow it for residential. So with that, and that would not be a cost increase and potential cost reduction in that it could allow for shorter duct length. So is an agreement on that?
Great.
So Laura, let's add that in.
Can you send that to me, Tim?
I can. I will email you.
Thank you.
And we can bring back up on the screen. Let's go to 505.7. In our matrix, we have trying to remember the open item here. Oh, okay, we're going back to, as part of our incorporation of the construction provisions of the fire code and the that there are safety items that are required when you have a stove in some of the I occupancies. So when there's a stove, that there's some, the basic requirement is that you need a UL 300A type range hood, which has some minimum integrated fire protection in it. And it also has the ability to cut power to the cooking appliance This was in the code in the last code cycle and has been effectively for some time. But what we wanted to make sure is the one item in this change where they're being more explicit about it in the use of range hoods is that it does have a minimum airflow associated with it of 500 CFM. And just wanted to get one last note from the group that that isn't in the current code of having a specific CFM of exhaust from range hoods in these eye occupancies. And just one more time going through the group, if they're doing this, there's a potential cost increase involved if some of these UL 300A units were under 500 CFM. So, and it also potentially would have impacts on even more potential makeup air. So, bringing this up for discussion just one last time to say, go forward as in model code with adding this new requirement for a minimum CFM on the unit. And just with a note to that there is a fiscal impact. Wanted to allow people a little extra time to mull that one over last week.
Thanks, Mark.
I wouldn't say I have any reason to differ from the model code on this one, Mike. So that's my personal opinion. I don't have a reason.
All right. Any other comments for the group? If not, we'll just put this forward with fiscal impact. Cost increase.
Yeah, I don't have any issues with it, with the model code. I think we should go forward with it.
Okay. All right, so we'll add with fiscal to 5057 and 5058. Last, going back to our review item, let's get refrigeration piping and shafts out of the way in 11 first, and then we'll go back to ventilation to get that done. Okay, let's go to... Oh, excuse me. The 11 is not the refrigeration and shafts. It's the new, it's just the new note, informative note that we're putting in just to run this by everyone. I want to show, to remind people of what an informative note is that we do have when other regulations might be applicable to the code, they're set by other people. We wanted to note that there are requirements for refrigeration repair technicians that are outside the code, but it's sort of noting some of these environmental issues that are out there. We make notes about DEQ requirements, Oregon and federal DEQ requirements for wood stoves. Just felt that letting people know that we're going to have this informative note and get feedback about, you know, service technicians, especially now that we're seeing a lot of work on changing the refrigerants that are required. Just note this is not code, but a recognition and informative that service techs and needing the EPA certs for doing work. And just want to get a little feedback, especially from the contractors in the group. This is something that the division normally puts in, but just bringing it out for awareness to the group. And since we did have on here about refrigerant piping and shafts, I believe that was approved last time, but for some reason I had a note about that to continue to note and actually show the language change that's being put forward, which is, and we had that. You showed the strikeout just a second ago. This was a recommendation in 1109.2.5, and it is catching up with what is in the ASHRAE refrigeration standard and is going to go into the 2027. Striking out, as we see in exception number 2 here, using group A1 refrigerant. Any refrigerant that is above the MAQ limits and requiring refrigeration will need the doesn't need to be in a shaft, and actually could be a 1 hour or even a 2 hour shaft. So if the piping is allowed to be in the building, and is in a safe quantity to where it doesn't present a hazard and fall under the, maximum limits under the tables, this is just noting that, unfortunately, yeah, because of all the new refrigerants that are coming out, limiting that exception just to A1 refrigerants was going to be a big cost impact unless that was modified, and just putting that forward to the group to let you know about and to actually show what the language would look like in our code and will look like in the 2027 IMC. Any comments from the group? Further from last week?
This is something we've been talking about here, Mark, with the new refrigerants and the implications of the rated shaft. So this will be a change people are interested in. This seems like it could be a significant cost savings, if I'm understanding correctly, right? We could use an A2L without a rated shaft through more than 2 floors.
Yes, that was when they brought in a lot of the language from the latest ASHRAE standards, they missed this one part. We reference the standard in a lot of places, but this language from, I believe it's 15 and 34, just was missed. And they realized, oops, all the refrigerants are changing soon. And so they're getting it into the next model code. This is one area where we're looking to catch up earlier, with language that is a significant cost impact for us here. So just moving forward, if there are no further comments, with that as not having a cost impact, we will go to chapter 4 and some of the R2, R3, R4 occupancy language, and have that for discussion today. So beginning with 401.2, previously, model code language says, if you're complying with the energy code and the leakage requirements, which we require, dwelling units are required to have mechanical ventilation in accordance with section 403. That's sort of our starting point. That's just clarifying to standard to align with code language. What we need to do is go to 403.1 and show some of the model code changes, and one that was missed in the public document that we'll go through. But if we can go down to 403.1. Yeah. Oh, Laura, are you looking for me to talk about also the exception here? We had published, while we're in 401.2, the exception that's being shown here about the way the language worked for the differences between what's in 403.2 dwelling units under 4 stories and dwelling units above 4 stories. We wanted to make sure that no one got out of having to actually ventilate a shower or bathtub room in a private dwelling. There was actually potentially an out the way our code was currently written. So that's the reason for the red line. You see they're deleting that exception. There's no need to have that in this code cycle. So we will go down to also, we're here that, quote, natural ventilation, as we had noted earlier, has been brought in to the mechanical code. The folks at the building code side said, look, just put all ventilation in whether natural or mechanical over in the mechanical code instead of having it in different locations. They're recognizing that decisions will all be over here by the mechanical design team. So that's why the informative note was struck. Let's come down here.
Mark, do you want to go over I sent all of the committee members the document.
Yeah.
This.
So we have sent out just sort of some general guidelines for sort of discussion of, what is going on, what's changed, what's happening at national level, local level, the things that we've done here in Oregon for our discussion today. I don't know if everybody's had a chance to look at it or not. I'm bringing up my copy. There were sort of a list of general questions for everyone to potentially go through, looking at the, yeah, here it is. Laura brought it up. Thank you for first showing what happened at the model code, or excuse me, at the building code side of moving natural ventilation over to 1202 is being moved to where natural ventilation is being done over on natural and mechanical ventilation are all being done by the mechanical code. So that is what the Oregon Structural Specialty Code has done, is that, and also noting that dwelling units in R2, 3, and 4 occupancies need to be ventilated by mechanical means. So, and that ambulatory facilities and I2 occupancies need to be mechanically ventilated as well in accordance with the mechanical code. So they're clarifying on their side that they need to know who does what ventilation, where, and how. So moving over to our code, we're going down through the list, is that section 401.2, ventilation required. 402 now is officially in the mechanical code once again about natural ventilation, no modifications to that section. 403 is for mechanical ventilation, and it requires that all dwelling units are ventilated by mechanical means in accordance with section 403. We're getting rid of our exception about or pointing out that bathrooms have to be ventilated. That's now covered between the tables. Section 402, we're rescinding that previous amendment that said that the mechanical code didn't cover natural ventilation. It is now in the mechanical code. Then in 403.1, we're going through R2, R3, and 4 occupancies. Exhaust, the ventilation is exhaust, supply, system, or combination thereof is allowed under model code and has been in our code. And then all other buildings are supply, return, or exhaust air for their mechanical ventilation.
So Mark, what I'm going to do is send everybody in the chat, since we have quite a few. Our streaming is not working right now, so everybody's joining. So I'm going to share the committee only page in the chat for the Zoom, but show that page, the analysis page, so that everybody can follow along in the code doc, but we'll show on the stream the analysis page. Oh, give me a second.
While that's coming up, one of the big changes for this code cycle is that for dwelling units, if you were 3 stories and under, you were in section 403.3.2. But if you were in a high rise or 4 stories and higher, you were under the ventilation tables. What has happened is also in alignment with what's happened at 62.1 and 62.2 is that any dwelling unit, if you're an R2, 3, or 4 occupancy, you're going to use the residential section under 403.3.2. If your other buildings, you're using 403.3.1.1 and the complexity when you get into multi-zone systems and the like. But dwelling units, really, if you are a apartment or condominium, or if you're a dwelling unit, you are in this section 403.3.2, and then we'll go over sort of the Oregon changes on that and discuss what happened at model code as well with this modification. But this is simplifying application. The good part is it's simplifying the application for any dwelling unit in those occupancies. You're not going to a different methodology when you're in a high-rise building versus 3 stories or 2 stories of residential over 1 story of commercial. So it makes it a lot easier to work on that. So under 4033 at model code language, they fixed the strikeout of group R2, R3, and you see 403.3, group R2, 3, and 4 occupancies, 3 stories and less in height above grade plane has been struck. This will now be for all of those. You go to section R403.3.2. So
And that will be errata. It should be errata in the IMC when they come out with it, because they didn't like that in 403.3.
So let's go to 403.3.2 to go over both Oregon amendments or real quick before we get there, let's go back up in the table. What is in our current table to explain some other items we're looking at is, let's scroll down until we find a stop. Whoa. Back up just a little more. A little more. Here we go. Private dwellings and single and multiple. This used to be for all things 3 stories and higher. What we do in our code is, and what will remain, sometimes there may be a private dwelling in something that isn't in those occupancies. They sometimes have a small apartment or dwelling at a storage facility or something like this. We'll make sure that there is alignment, sort of with model code, and making sure that the Oregon amendments stay in place. If we'll look at private dwelling, single and multiple, under kitchens, Oregon has had 150 CFM as the minimum for kitchens. We're going to maintain that for when it's intermittent operation of a kitchen. Another item is, of course, under toilets and bathrooms, Oregon has gone from 50 CFM to 80 CFM if there's intermittent operation. And we also, oops, can we go back to that? Because I want to show the footnotes here, because that explains a little more on this. There is a footnote in Oregon for toilets and bathrooms, footnotes G, M, and N. G is, of course, noting about just environmental air. M is a existing change that applies an existing Oregon amendment in this table that aligns with our residential code, that all rooms containing bathing or spa facilities shall be provided with a mechanical ventilation system controlled by a dehumidistat, timer, or similar automatic control. And we need to do and then it says, and then we have the note about sound for intermittent operation. We do need to, and I noticed this, Laura, that we need to clarify that if it's intermittent operation, it needs to be controlled. That's the intent of footnote M.
Oh, okay. So you want me to add that here as
Yes,
well?
I forgot to get that in there. At the very end of the sentence, let's just put as with a dehumidistat, timer, or similar means of automatic control for when intermittent operation.
Can I just copy that other one that we did?
Okay, yeah, we can copy the other one.
It's facilities with intermittent exhaust
Okay.
shall be provided. That's what we came up with.
We're looking to make sure that this requirement, which is in the residential code and is currently for 4-story and higher, okay. that it is only applying to intermittent fans. We don't want fans that are running continuously to potentially be on a time clock or other automatic control that would shut it off. This is intended for, just like in the residential code, for those fans. So those were the notes I wanted to point out there. Let's go down to 4033 now, or 40332. And the model code changes that are here. One thing that I believe this was where, yeah, we have made sure in one of the locations where there's talk about R2, 3, and 4 occupancies, 3 stories and less, all of those have been stricken to make sure that this section here for the ventilation for dwelling units is per code. We do have the modifications similar to that have been in code for some time, that it is an 80 CFM bathroom fan if it's intermittent. It is 150 CFM if it's direct vented, or excuse me, for a kitchen fan. These are where Oregon has had a higher requirement than model code. I want to make sure that that is happening as well. And then we're going to point out part of the discussion today. Oh, if we are you going to stay there, Laura?
No, where do you want me to go?
Let's scroll down to the ventilation rates, just showing the schedule here is that, we do have a higher rates for intermittent kitchen range hood exhaust and for bathroom exhaust. It's worked very well for us. It's had great results in Oregon, and we're maintaining that. We are making sure that, yes, that bringing in the requirement for all dwelling units that if it's an intermittent bath fan, have that push button or humidistat or other controls that can allow, which came from the Construction Claims Task Force in 2009, and really was intended for all dwelling units. When this section was put in, it was kind of missed to make sure we had the controlled fans, but this maintains alignment with the residential code. And so those are the changes. Now, the one item for discussion today is a fairly significant change under equation 4-9. Currently, and for some time, the ventilation rate has been 0.1 time the total CFM required for the mechanical ventilation, if you were going a mechanical ventilation, was 0.1 times the area of the floor plus 7.5 times the number of bedrooms plus 1. So really, if you had a one bedroom apartment, you did 2 times 7.5. That's an additional 15 CFM. The change from 0.1 to 0.3 is a range of 30 to 40, 45% increase in the ventilation rate under this section. And we're asking for a review on this and whether to move this forward, because there is a cost impact on that. And whether, given other items that we're doing, the division is recommending some either maintaining the 0.01 or maybe going to 0.02. The 0.03 is a relatively high increase, but we're asking for your consideration on this one, but and to consider any cost impacts with that. So division's recommendation is no more than changing that number from 0.01 to 0.02 times the floor area. And we're going to have discussion among the committee first. Any committee members?
Yeah, Mark, again, I don't think I have any expertise to comment one way or the other. And I'm sorry if I missed this when you said it, but do we have a specific justification for differing from the model code on the ventilation rate per floor area, the study or anything that we're referring
We've
to?
had We go a little further than model code for general ventilation for our bathrooms. And this is there was plenty of discussion at the model code level over this. So,
Okay. Yeah, I have no
it's something that
exceptions.
the division would probably the division will be recommending that if we're going to do an increase, not going past 0.02. That will be our recommendation. And do you wish to hear from Mr. Moore?
Sure.
Okay.
Thank you. Mike Moore, Stater LLC. I am the prior chair of ASHRAE 62.2, and mea culpa moment here. I'm responsible for that 0.01 getting into the code originally, and responsible for for changing it back to 0.03, at least from a proposal standpoint. The reason that it was actually around 0.03 before. If you look at the tables that Mark had referenced previously, in the non-transient dwelling unit space there, if you use the ventilation rate table there and you calculate the rate for a dwelling unit, it's pretty comparable to the 0.03 that you're seeing now. What happened was, in a few code cycles back, I was on 62.2 and I was trying to promulgate 62.2 rates. Problem was, at the time, 62.2 was based on single family dwelling units, or focused on that. And so all the rates were, the 0.01 was based on that and assumed an infiltration rate associated, like an air leakage of the building enclosure. And so there was a credit that was built into that equation associated with a typical leakage rate. What happened was 62.2 then recognized that the building code is moving away from that and saying build tighter. And we can no longer assume that homes are as leaky as 7 ACH 50. And this is especially true of multifamily dwelling units that have adjacent units, where you don't want to build in an infiltration rate assumption, because you're likely to be drawing the air from the corridor, or from the unit next door as likely to do that as from outdoors. So 62.2 moved to say that if you're an attached dwelling unit, we're going to 0.03, which is more in line with where the IMC was originally. And then I had to go back through and correct everything in the IMC to bring things back in line. So the 0.03 is really supported by 62.2 at this point, also by the model code for low rise, and it's akin to what was previously required for I should say for low rise and high rise, and akin to what was previously required for low rise and high rise by the IMC prior to parsing out 403.2 into its own section.
All right. Thank you. Excellent, mea culpa.
Yeah, it's very helpful. Thank you.
You bet. And sorry about the confusion.
So, Mark, maybe can you reiterate, and I guess I'm trying to put all the pieces together here, but is Mike suggesting he'd prefer to go to the 0.03, but now the committee is saying if we do increase it back, we're going to limit the increase to 0.02 and kind of meet in the middle? And I guess I'd like to understand everybody's position on that and what Mike's recommendation is on what that value should be.
Okay. Division position is, yes, that many of the things that are needed to be addressed in residential, we do much better on in the state of Oregon. That the 0.01, with an allowance to go even lower if you did a distributed and balanced system, and which there are different states have, if you do a balanced system, you can reduce some, but this is only if a distributed and balanced, you get a reduction. That we're looking at some of the testimony that was put forward from people like Joe Stieberich and some other experts, that we're trying to find, is there a need for a full 40% increase beyond what has been constructed for some time in the state? Are we seeing activity that is requiring that big of a jump
And
from current standards.
moving to 0.03 from 0.01 represents a 40% increase.
Yes.
Is that right? Okay.
Yes. On average, depending on of course, the size of the apartment, number of bedrooms, but for a typical one bedroom, or there are a lot of about 1,000 square foot, 2-bedroom apartments. On those, it's about a 40% increase. Yes. So that's part of the reasoning, is that yes, we've had what it has been in code for some time for low rise, but also yes, single family homes have a lot more leakage in a different area. How much more do we really need to take things forward when we are giving a lot of consideration, both to, from our standpoint, asking to look at this from both affordability and from energy impacts of a 24/7, 365 days a year change in the ventilation rate, of giving taking some time to really think of this over versus, is there a demonstrated need to go that much more? Is really our question that we want to make sure everyone has thought about.
Got it. Is there, and I'm not a single family expert, so apologies, but I don't know if there's currently a infiltration requirement on single family, and if
3
we can
ACH 50 for Oregon,
3 ACH 50. Okay, so
or for model code.
got
In
it.
cold climates, 5 for warmer climates.
So the Sept and the 0.01 was based on a 7 ACH 50, and was actually, I guess there was some math that backed up that infiltration was taking that number down to that, or is that?
That's correct.
And at 3 ACH 50, that number should change. Is there, an analogous, I guess, equation? And I know the infiltration varies, so we're talking about kind of a dynamic amount of air that's infiltrating, but
so yes, and we could share division look at some national or the difference in air quality based on the Offerman when you go from above, and we'll call this 0.35 air changes per hour, and a air change rate under 5. And the difference is, we really looked at this closely, of how much of a difference there is in the indoor air quality based upon the results of one of the more extensive studies ever done. Did anything get worse? Measurably, significantly worse, and we did not see that. So that's why we're really asking for a close look on this, is that they did tracer gas. They looked at pretty much everything under the sun on that. And when you separated out buildings that were under 0.35 CF or ACH natural, so that's the intended, what makes home safe. If you were under that limit and the home was also well sealed, the differences were nothing got anywhere close to hazardous work, but maybe 1 to 5% worse than the baseline building, or buildings that were very leaky. The difference was very insignificant. So that's one of the reasons why we're looking at this closely and have done a bit of review on it.
Mark, am I able to respond to the question about what my recommendation would be?
It's up to the committee, yes, but yes, go ahead.
Well, I'd like to hear it.
Yeah.
All right, thank you for that opportunity. Yeah, so I would recommend going with the ASHRAE equation, the model code equation in this regard. I don't believe, Mark, please correct me if I'm wrong, don't believe the Offerman study looked at multifamily. And in multifamily, you have higher concentration of occupants, and based on the floor area, who are still, using cleaning agents in the house, and going about their daily lives and creating pollutants through cooking and other just interactions that they have. So that's something that should be considered here for multifamily as well, which I'm not sure has been built into the recommendation. And yeah, it's where we were before again. So it's not really a 40%. You could look at it as a 40% increase from where we are today, but really it's getting back to the levels where we were before. Before we assumed that a multifamily unit was just like a single family dwelling unit with a 7 ACH 50 leakage rate. So this takes us back to where we were before and corrects the mistake of making that assumption that I personally built into the code.
And I'll just give one more comment on that. Beforehand, natural ventilation was still allowed for prior to that. So the up until, when we're moving to mandatory mechanical ventilation, that's the issue I'm bringing up. When before this started dividing, there was still natural ventilation path in the state of Oregon prior to this. So if you did not have enough windows, yes, and you went with mechanical ventilation, that was approximately the area. But we have how many decades of homes in multifamily that many were using natural ventilation path. So that's part of the, just making everyone aware on that too. It wasn't required before this.
Thanks, Mark. That's a good clarification. Mark, just the concern with the 0.03 is purely the cost impacts that would have on projects. Is that correct?
Energy as well.
Okay. And are you, I don't know if you're speaking, for that side of things or not, but is that concern more around single family or multifamily or both?
All. But both. It is.
Okay.
Again, we're being directed so we're having pressure from keep housing affordable. Also looking at energy impacts. So we have to go, where were we? What are the impacts? So that's the reason why we're just making this a very asking for close look this time on this when it's a potential cost and so energy impact. How much correction is actually needed this cycle to maintain good, safe, healthy, and we haven't even gotten into whether or not we have methodology to actually shut off the systems when there's a high smoke event or something like that, which has been another ask from.
Right.
Smoke is very big on everyone's minds these days, but that's not currently part of the discussion today.
Yeah. Yeah, Mark, I agree with you're wanting to take a very close look at it. It does seem like a very important topic today, and indoor air quality has become increasingly important in residential and commercial, and we talk about it all the time, and the trade-offs with cost and energy. The study that you referenced that indicated there, would be a diminished return of air quality beyond where we're at, or certainly beyond a 0.02, I thought was interesting. But then to hear that only applied to single family and that study doesn't apply at all to multifamily, if that's correct, would be a good clarification.
It was looking at single family homes, yes, but the data that was used was whether or not it was looking at the air change and the ceiling of the home itself. So how much it truly measured exactly how the actual amount of outdoor air that was moving through the home, the ACH natural. So during normal operations, real world, what happens on a home when it was tightly sealed and had a low air turnover rate. So below the recommended 0.35 air change natural, what was happening there? So seeing when there's a resident, it's sealed.
Yeah, fair enough.
Turnover, how much difference was there in the contaminants, CO2, et cetera, for those homes?
Right. So you're saying that
whether it was
the
just
air
dwelling
infiltration would be comparable to multifamily, whether or not it was done in a dwelling unit, because it was 0.35.
Yeah.
Yeah, that's interesting. I guess, Mark, and I don't want to talk too much. I want to let others talk if they have anything to say. But lastly, I mean, it's just my impression is that ASHRAE has a fairly robust kind of research process in determining how those standards are determined. So maybe maybe that's wrong. I haven't sat on an ASHRAE committee, but I thought it's generally robust, right? So like I wouldn't personally feel comfortable overruling it with what I know, right? Without doing research and seeing how the research was done and going away from it. So that's my piece. But
Okay, thank you.
So as a contractor and an occupier of multifamily and single family and hotels and motels, and one of my biggest pet peeves is a lack of ventilation. And I think I like Oregon leading the way here with promoting more than the minimum industry standard from a ventilation point of view. I understand it increases cost, but I think indoor air quality is super important and ventilation is very critical to that. So that's my 2 bits.
Okay. All right. Looks like so the changes that have been put forward with the 0.03 and the prior Oregon amendments and updating the amendments to make sure we've got the control on the bath fans. Recommending that move forward, correct? Unless there are any other comments? And recognizing costs, correct?
Mark, does anybody speak to what we think the cost impact is, or just that there is a cost impact?
Pierre?
No, you got, yeah, it's encouraged to speak on what the cost impact would be, and any detail would help me.
So we're requiring more CFM per square foot of conditioned area. Is that correct, Mark?
Correct.
So we are going, but we're not, this isn't a new requirement.
For this so everyone under 3 stories and under. So this will be something that we'll have to take to, and get, because it affects 3-story and under, the residential board will get a chance to say something on it because that is under their statutory authority. But so,
okay, well,
but for above 3 stories, above 3 stories would not be a significant cost impact, but this would be for our 3 and under.
So for 3 and under, there is a cost impact.
Yes.
Yep.
And we're talking about throwing in an ERV, something like this. Nope.
It can be supply, exhaust, or any combination thereof. If you are above 60 CFM for the dwelling unit, it will be an ERV on it.
Can we defer to the residential board to give us some feedback in this regard, knowing there will be cost impact?
They can then accept or say, that they'll give their feedback on it. And I believe they could then say that, yeah, in their code for apartment, but they normally will accept what's done from this board, but they do have the chance to provide feedback on that. Because they are any changes that affect them are brought before their board.
Yes, correct.
A dollar amount, I mean, a value. As a contractor who does some residential, I mean, I can see it going a couple different ways. I mean, it could be a supply air, some exhaust, and then tying it into the supply air. Yeah, it can be a $800 to a $1,200 impact per zone.
So
I think.
Can you elaborate a little bit, Jay?
Cutting in a louver and connecting uh, uh, the damper bypass for that, and the electrical and the control for that. I'd rather see an ERV go in and have it piped in directly to the supply air, pulling from the return and going into the supply air.
So
That's more.
it could be as little as providing a bath fan that is larger and more exhaust, and finding some way, to and outdoor air through current methods, but it could be as little as upgrade on the exhaust system.
Thank you, by the way.
And that can be down in the $800 range.
Yeah. Okay.
Everything's just so freaking expensive these days.
All right. We can then.
That's what I would propose.
I would just go by the BCD's recommendation of just going 0.02 then instead of the 0.03. It'll cut down on the cost.
Yeah, I think the cost that we're discussing is really, the amount for going to the increased quantity. So it may be more in the 200 to 400 range, probably
I can see that.
at most. Yeah. So is that agreeable?
That sounds good.
All right. I believe, are there any other portions from the matrix that you'd like to re-examine, or are we? I believe that was our last item on the agenda for today. And the last item still open on the matrix, if I remember.
Was there anything else?
May I say one more thing? This is Mike Moore.
Go ahead.
Okay, thank you. Yes, so I just wanted to provide a little information to the committee. The action that you guys took on the intermittent bath fan controls is aligned with the 2024 IECCR section R40365. Now has some requirements that are similar to Oregon, so that just shows, Oregon leading the way is definitely trickling down there. So that's great to see. And also the incremental cost associated with going to 0.03 multiplier versus 0.01 could be as little as effectively as little as $0, because it's depending on the ventilation rate, right? Because if you're moving, say, from 35 CFM to 50 CFM, and you're using a bathroom exhaust fan, let's say, it's really hard to source a bathroom exhaust fan that's going to provide less than 50 CFM, because they're designed for bathrooms where that's a minimum code requirement for the model code. So you might not have any incremental costs associated with that increase from a first cost perspective. There are of course energy considerations, but it could be as low as $0, practically speaking. Thanks.
Yeah. We'll note a range. How about? Any further comments today? Any other items to re-examine or further discussion on? All right. It looks like we have a recommendation, group of good modifications that have come out of the group. Close look at, fortunately, a very limited number of model code changes this go round, and good recommendations we can move forward to the mechanical board for their review and consideration at the next mechanical board meeting. Anything else we need to note from a admin standpoint, either Pierre or Laura?
No, I think
Oh, no, nothing needed from me right now.
Okay. Wow. Like to thank the folks who came in for the committee, and really good recommendations, good discussions on not a lot this code cycle, which is really good, which be glad you're not on the structural board review committee. And with that, I'd like to thank the members and the public who have participated. If again, you can follow, there's participation available at the board review. For further comments, there'll be announcements on that coming shortly. Any other ways, Laura or Pierre, for providing? I think that's the next go round, and then at the final code recommendation hearing.
Yep, sounds good.
All
Which
right.
is that's the 22nd, isn't it? Which is the next mechanical board meeting, which I imagine we were going to be reviewing this.
Yes.
October 22nd.
October 22nd.
Yeah, it's currently, I believe Katie rescheduled it for October 22nd, Jay.
Yeah.
So
Thank you.
time for review. Thank you very much, Chair Hansen. And we look forward to seeing you on the 22nd. With that, I believe we can conclude the mechanical committee, code committee review. Thanks, everyone. Really appreciate it.
Thank you all.
Look forward to any further comments at the board.
Thanks,
Bye now.
Mark. Really appreciate
Bye,
it.
everybody.
Thank you, everyone.
Thank you.